Okay, Yassi, I've started recording. So if you'd like to introduce this series and Isip, thank you.
Sure. Thank you so much, Susan. Hi, everyone. I'm Yassi Moghadam. I'm the Executive Director of International Society of Service Innovation Professionals, ISIP. And I've put our URL in the chat. I'm really happy that we've been collaborating with IBM for the last 4 years. And with Susan over the last year in promoting these series. We promote service innovation, and we define service innovation as application of knowledge and creativity for the co-creation of value. And AI is probably in this century the most important enabler of service innovation. So that's why these calls are really important, and we're really happy to be collaborating with IBM on this. We have programs in OpenAI and cataloging OpenAI services. So I encourage you to go to izip.org, and I'll put the membership page also up. And please join us. So thank you so much.
Thank you, Yassi. Now what I'm going to do is show the initial slide for the talk today, and with the names of all the people who worked on the paper on which this talk today is based. And I'd like to briefly ask the people who worked on the paper maybe to say hi. So Cedric is going to present, so I'm not going to ask him. Ludovic, are you on? And do you want to unmute yourself and say hi?
Hello, everybody.
Hello. Where are you? Where are you, Ludo?
Yes, I'm located in Grenoble, so in
Grenoble.
Yeah, in France.
Okay, and I see France is on, aren't you? Yeah.
Yes, I am.
Hello, France. And where are you located?
Paris area.
Oh, you're okay. Great. So we have diverse locations here. And Jean-Armand, you worked on the paper as well.
Yes. Hello. So I'm located in Montpellier as well.
Right. And I think all the people who said hi so far are from Atos. And then I think we have Mark on the call. Mark?
Yes. Hi, this is Mark West. I'm with IBM. I'm located in Indianapolis, Indiana, United States.
Okay, great. And Rajesh is going to be speaking later, so he can say hi later. So you can see we have a range of people, and they all work in different areas of their companies. So I'm going to hand over now to Cedric to introduce this work that started in April earlier this year. So Cedric, do you want to start sharing?
Yes. Hi, everybody. So I'm going to share my screen. Is it okay, Susan? Do you see my screen?
It's excellent.
Okay, perfect. So I'm Cedric Bourrasset. As Jean-Armand, I'm based in Montpellier in the south of France, and I'm an AI project manager in Atos. So I'm in charge of developing the AI portfolio of Atos. So if you can see my screen, you can see the name of the paper we have jointly published between IBM and Atos. So it's a requirement for an AI enterprise benchmark. So first, I would like to thank everyone who collaborated on the paper. And I will give you the motivation of this work, and then we will go more in detail with research. So first, what is important to say is that we have some similar challenging in IBM and Atos when we are delivering platforms and solutions for enterprise customer. And when we need to deploy a system on-prem for some customer, we need to take some engagement. And basically, with the AI domain that is very hyped today, we have some challenging when we are taking our engagement with customers. So we are basically taking some custom engagement with each customer, because as challenge we need to set and to define many different things with our customer, because AI is covering today a large set of processing, of workflow, of hardware, software, and framework. And basically, when you need to engage your company for on-prem delivery, you need to clearly define with your customer what will be measured and what is the engagement. So basically, we have those similar challenges between IBM and Atos. And when we met in Paris early this year, we have decided to launch a joint initiative between our two companies to build a team and interview our existing customers, share our knowledge, or we address the markets today, or we provide themselves to our customer, and try to define which are the bottleneck, which part of the process is relevant for our customer. Is it in data preparation, data cleaning, model trainings, or using of the performance of model in production at the end? Are we benchmarking just hardware, just software, or end-to-end solution? And which metrics we are using to be sure that we are comparing the same thing at the end? And with all those freedom and degree of liberty in taking engagement with customer, we are trying to define and to look at which existing benchmark we can use and map to address this challenge. So we share our experience and knowledge between the IBM and Atos teams. We look at some benchmark, and decided to write a paper and share all the information we have gathered during this initiative to the community, and to try to move on and to have a kind of standardized way of evaluating a performance, because we think that it would be benefit for our company to have clear standardized way of benchmarking AI for the customer. So that was the motivation of this work. And so this talk will review what we have done in this joint initiative and what we have written in the paper. So we will review what are the challenges, the metrics we have defined for enterprise workforce, the benchmark that are available today, what they are covering, what they are not covering, and what are the gap between existing benchmark for AI and the gap between the benchmark and the metrics today that we need today. So basically, we have identified 3 main areas of concern for our customer. The first one is around the training of a model and the performance of a model training, including a very important part, which is the data labeling and data preparation. We will see that in most of the benchmark today, this part are not very well covered in benchmark, and at the end, it's very time consuming. So we will focus on training performance, so data labeling, time to accuracy, and some compute and throughput metrics. The second main area we will cover is about hyperparameter optimization performance, which wasn't addressed in the first benchmark we have in AI. We are starting to have some reference with the new MLPerf initiative that gives the capability of addressing hyperparameter optimizations, but it's a very important area for optimizing a training's performance of a model. And the third one is using the model in production, so the inference runtime performance. So we will cover in this talk those 3 areas and try to give you some information about workload profile, which performance indicators are good to assess if a task is efficient on a solution, and some potential bottleneck you have to look at for taking AI engagement. So I can give the floor to Rajesh if he wants to go through the model trainings. Rajesh, you?
Thank you. I can actually use your screen if it's okay.
Yes.
Okay, thank you.
Yeah. Of course.
So as Cedric mentioned, there are 3 different components in a traditional deep learning workload scenario, and we'll go through the details. So these 3 components include model training, hyperparameter optimization, and the inference. So this slide kind of talks about what are the different issues with model training. And so we have kind of identified certain dimensions over which the model training can be characterized, which include the workload profile, the corresponding performance indicators, the technical bottlenecks, and if we have to implement those in a concurrent, more of an distributed or concurrent scenario, what could be, potential or new kinds of bottlenecks that may incur. So first of all, model training can be viewed as a batch task, which traditionally involves fetching data from the input training set and kind of doing some initial pre-processing and then sending it to a compute engine, and most likely is a set of GPUs, and then kind of getting the result and storing it back. The performance indicator of a batch task is usually the time for training, and if it is done in a distributed environment, what would be the scalability of the overall system? How does it scale with the number of CPUs? How does it scale with the number of GPUs, and so on? Traditionally, this is both memory or IO intensive as well as GPU intensive workload, or I would say compute intensive workloads. In most traditional deep learning scenarios, for example, doing for image processing, for example, or even for speech processing, the traditional deep learning pipeline consists of a layer of CNNs, which are traditionally for feature extractions, followed by a set of MLP layers for classification. And this is a standard pipeline, but in the newer versions, for example, for residual networks or for some of the language translation networks, the depth of the pipeline is very large, as well as there are more computationally intensive components that are generated due to the type of neural network layer. It may be recurrent layer, or it can be LSTM GRU layer, for example, for processing sequences like speech. So at the end, the overall application or the training process becomes compute bound. So in reality, right now, this becomes a GPU intensive workload, and for many scenarios where you have you need to achieve certain accuracy, the total time is now from minutes to days, and earlier image processing was one of the kind of a driving force for the model training, but now it has shifted to NLP and kind of a sequence translation component, which take even longer time. So overall, and we believe that with the future newer workloads such as attention models, the training time is also is going to increase even further. So given this scenario, we need to understand what are the performance indicators, and these includes the total cost of ownership, the cost of acquisition, and understanding the price to performance metric, whether it is worth buying a high-end GPU if it is not really giving us any gains, whether we can do the similar, we get the similar timing with a equivalent older generation GPU or a different GPU. If we need concurrent scenarios where you can do it on one GPU, you can do it on 4 GPUs, how many number of machines you need, then what is the whether the data fits in the CPU memory, whether it fits in GPU memory. Do you need out of core computation, so the models are larger, whether you need what kind of network do you need? Do you need something like InfiniBand? Do you need or a 100 gig will suffice? And all these issues, they lead to these are the current issues, but they would even have as we are thinking ahead, we are going to see much longer times with new kinds of data, and with larger model that would that would be more lead to out of core computation. So the memory footprint is going to be large. So all these issues we need to capture in the benchmark and kind of evaluate in the context of an end-to-end system. So next slide, please.
Yep.
So now an orthogonal problem to model training is hyperparameter optimization. So the hyperparameter optimization is intimately related to the accuracy and the time for execution. And there are several ways of doing hyperparameter optimization, and in many cases, the process of choosing the right parameters becomes a computationally intensive and long-running task as well. And we need to understand how the workload characteristics and how to optimize that, the cost of hyperparameter optimization, whether we can do it in parallel, whether we can do it on GPUs, what is the best way of improving the performance if it is being done in the context of a Python code, or it is done in context of some other deep learning infrastructure. So all these issues are important to and something like the hyperparameter server cost model is not also not viewed as part of a end-to-end benchmark, which is another issue that we want to highlight. And next slide, please. So the last part is after the model is trained, to use it in a runtime inference environment. And I think this aspect is more widely known than the training aspect. However, there are certain issues that are not that arise when we incorporate a model inference from an enterprise perspective. First of all, we need to understand the overall scenario in which the model inference is used. Is it what is the APIs being used? Is it being used in a online service on a cloud? Whether it is part of some overall transactional workload that has certain real-time response time constraints. Whether, and based on the response time constraint, then we need to decide on an accelerator story. Potentially, it can be a low power GPU like a Xavier system or an FPGA, or a specialized ASIC can do the job as well. Again, the performance is dependent on many factors, and the definition of performance is also different than from a training perspective. So here, in addition to the accuracy, the time or the latency of inference is extremely important. In many cases, the inference is done as one of the components of an end-to-end pipeline. The scenario can be either for a transactional system in an OLTP scenario, or in an embedded or autonomous system like robos, or for example even for autonomous cars. So the performance indicators include latency of inference, the accuracy, as well as the power performance, and in many cases the cost of ownership of acquisition and total cost of ownership as well. Unlike the training, the memory footprint is smaller for inference. However, given the real-time constraints that someone has to implement, the inference on let's say an embedded system, the RAM issue can become a problem. So it's not always possible to have very large memory systems. So in some scenarios, the inference problem can lead to an out of core or large memory scenario. In addition to that, since majority of inference problems are latency bound, the network infrastructure and communication characteristics become important as well. So Cedric, you can move to the next slide. So
yeah,
please let me know if you have any questions.
Yeah, we could take question, I think, at the end. Just to quickly go through existing AI benchmark in some conclusion. So Rajesh has, and thank for that, has presented the bottleneck, the workload profile for training, hyperparameter optimization, and inference. And so we have identified all those workload profile and bottleneck in real in metrics, existing metrics. And then when you are doing that, the other part is to identify existing AI benchmark and try to map them between a benchmark and between what you need to define to engage for payments with your customers. So today we have some existing benchmark, and it's a new, I would say, a new area of sharing, new benchmark, new sharing, development between the community. So I would say historically, I think it started by deep benchmark. So this benchmark, you may know from Baidu, targets low-level operations that are very important, mainly for deep learning, but basically they implemented some GMM, so matrix multiply operation, some convolution, and some first communication between, for example, GPU to GPU communication. And the idea of this benchmark is to have a low level of information about your hardware, or your hardware is able to run fast some low level operation. So it's very hardware benchmark, and you have some implementation of some one or two deep neural network inside, but it's very, the target is very benchmarking hardware. And then you are TensorFlow, which provides some benchmark and some performance benchmark that are similar to the bench. In fact, they are focusing on hardware with TensorFlow and with some middleware layers, just as NVIDIA GPU for NVIDIA Docker for NVIDIA GPU. But one of the issue of most of TensorFlow benchmark is that they're just focusing on throughput performance and no time to accuracy, and this very limitation. We think that it's a limitation when you want to assess a platform from one to another one. One of the first complete initiatives is DoneBench that now I think there's joined the MLPerf organization, but that DoneBench comes from Stanford, and it was one of the first benchmark that look at trainings, inference, but also performance and cost. So it's one of the first benchmark suite that has different metrics, but they are not addressing data preparation, for example, or hyperparameters optimization. And the latest, the more recent initiative is MLPerf that is going to growth and growth. And what is very interesting in MLPerf is that they are addressing benchmark domain per domain. So you have some deep learning, but for convolution, for image processing, you have some benchmark for NLP. So they address domain per domain, and they have defined something that is very important is the closed and open model. And basically in the closed model, you cannot set hyperparameters. Hyperparameters. So you define, the model is defined, the data is defined, and the hyperparameter are defined. So it's very good for having a fair comparison between hardware and software. And the second part is the open model division. And what is important in this is that the hyperparameter is let free to the company that will provide the benchmark. So if you have a solution that is able to optimize better your hyperparameter change during a training, that's you can see the impact of this tool on the MLPerf open model benchmark. So that's a very good approach for comparing hardware and comparing, I would say, high-level solution for hyperparameters tuning and so on. So that's for the existing benchmark. And in conclusion, so thanks for joining this call. So we have covered and shared the knowledge we have around AI workload profile, AI benchmark. And as you can see, we need to move forward to enhance it, to work with the community to set advanced benchmark and to try to have a standardized benchmark between academy, industry to be able to make some fair comparison. And for us, for our customer, it will be benefits to have this kind of benchmark. And what it is important for us and what we think is that benchmark very needs to be domain specific, so computer vision, NLP, and reinforcement learning, and so on and so forth. If you are interested in joining the initiative, you can contact Susan or any of the name of the people that were in the presentation. So you can contact me, Susan, Mark, Rajesh, and we will be happy to share and to work with you on this and to move forward on building this. So I think we have finished the presentation. So if you have questions, we will be happy to answer and to cover it.
Thank you very much. Oh, sorry.
No. And thanks
Thank you. Thank you, Cedric. Thank you, Rajesh. We do have Jean-Armand Broyel also on the call, who was deeply involved in this project. So before we go through the questions quickly, I wanted to ask Jean-Armand, you know, what do you see with the clients? What are the clients' needs for AI performance? We don't have much time, so if you know, but if you have something to share, that would be fantastic.
Yeah. Sure. So definitely they are looking for very high accuracy for the models. So that's first criteria, and for that we have to for sure explore a lot of different parameters for the hyperparameters. We have also to look for lots of different models, tune a lot, also the data set. So I think that this is really the highest criteria, and the training time is important. So it's a combination of time to accuracy, what the customer have seen looking for. They are doing a lot of also challenges. So some of them, are opening their data, and they can. I mean, IBM and other organizations can then have access to the data and create models. And after some months, they are looking for the best model. So definitely, it's accuracy.
Thank you very much, Jean-Armand. There are some questions in the chat. There's one: how might benchmarks work together? Deep Bench, TensorFlow, and so on, with regard to proprietary AI systems. Any thoughts on that? Have benchmarks been combined before in the past?
I think I don't know how you're addressing this on the IBM side, but basically what we are seeing is that you need to have a set of benchmarks. So Deep Bench for very low level stuff, and very low level benchmark in more MLPEF for application level. So basically, when you are engaged performance with enterprise customer, you need, and basically we have both benchmark, which is needed to give more information to the customer. So basically, we are running a set of benchmark. And we take engagement benchmark per benchmark.
Thank you, Cedric. There's another question: is it cost effective to overcome tech bottlenecks via the cloud? Where is the tipping point? Anyone?
I don't. Good question.
Yeah. One of the challenges during the training with cloud-based is the volumes of data. So some challenges that are really key to your evaluation as you consider cloud for the training.
Thank you, Mark. There was some discussion in the chat about the sort of doing inferencing on the edge versus doing inferencing at the core on GPUs, and the discussion went, it depends, what's going on. Anyone else have any responses to that?
I think the best answer is it depends. Yeah, it very depends on the workload. Basically, today we are seeing that some workload and some tasks can be put in the edge, and we are working on distributed video processing, and it's good for us to have some compute, some inference of model in the edge, because it reduces the bandwidth constraints. So basically we are making distributed computer vision in a set of cameras, in a network of camera, and it's very good for us to have edge computing and inference at the edge to reduce the bandwidth. On other workloads, we need more to keep the data somewhere centralized, controlled by the customer, and they don't want to have some information going on different devices. They prefer to take the information in a centralized way, in a secure system. And for this, we still continue to inference model in a centralized way.
Thank you.
Yeah, it depends.
Now, there is a point in the chat that this is a good start, but there's more to be done. So the next thing that's going to happen, Rajesh is going to present this work at the TPC conference, the benchmark conference at the Very Large Database event in South America next week. Rajesh, is that right? That's what you're going to be doing next. Maybe Rajesh isn't still on. We'll see. But after that, we'll be getting together to decide what to do next. And so we welcome feedback and how to go to the next stage. So anyway, thank you all so much for the talk and for the wonderful collaboration. And next week we have a completely different kind of talk about technology that's used in AI environments. So thank you everyone, and please thank the speakers, and the participants in this project in the chat, and I'll close the call.
And thank you for joining, and thank you, Suzanne, for organizing this call, and we'll continue to collaborate on this for sure.
Thank you, everyone.
Thank you. Bye.
Thank you. Bye-bye. Bye.